So now we're going to look at the area of a circle. So to remind us, the key parts of our circle were the circumference, that's the outside edge, the diameter, which was the line that crosses the center of our circle going from one side of the circumference to the other, and the radius, which is going from the center to the circumference of the circle. The area is the space inside the circle. So it's quite difficult for us to work out the area of a circle because of its curved edge. So let's do a bit of an experiment. I've got a circle here and I've split it into 4 quarters. And I'm going to color those quarters into different colors. Now, if I extract those quarters and try and make them into some sort of rectangular kind of parallelogram type shape, you can see that it doesn't work very well when I'm just using quarters because I've got those curved edges, so it would be quite difficult to work out what the total area was. So if I split my circle up into 8 segments, or eighths, then I'm going to find that if I transform it by extracting the pieces, that the curve on the top and the bottom of my shape is becoming less of a curve and more of a straight line. So if I chop my circle up into 16 segments, again, I transform it by extracting those segments, and again, you can see that the pieces are becoming more and more straight on the top and bottom edges until, as I tend to infinity, so if I had an infinite number of slices, they would be so thin that you would get pretty much a straight edge going across the top and the bottom. Now, the sides of my shape are a radius because they're the pieces going from the center to the circumference. The edges of the top and the bottom are equivalent to the circumference, and we know that the circumference in terms of the radius is 2 pi r. So that means if I have to split them between the top and the bottom, each of my edges is worth pi r. So thinking about my area of a parallelogram, which is the base times the height, or I'm thinking about my area of a rectangle, which is the length times the breadth, if I want to work out the area of this shape that I've formed, I'm going to do pi r times r. And that means that the area of a circle is pi r squared. So just like in the previous video, when we could use the c equals pi d formula to work out the circumference of the circle, we're going to use our a equals pi r squared formula to work out the area of a circle. So the first example, we're asked to calculate the area of this circle, and we want to round our answer to the nearest squared meter. And you can see we've got our circle, and we've got a radius marked on of 6 meters in length. So we're going to write down our formula, a equals pi r squared, and then we're going to substitute in our value for r. So we're going to type in pi times 6 squared. And if we've got a scientific calculator, that will give us a value of 113.097. And then we put the dots in to show that there are more numbers on our calculator screen. We want to round it to the nearest squared meter. So we're going to look at the digit after the decimal point. And if it's 5 or more, we're going to round up. If it's less than that, we're not. So we're going to round this to 113 squared meters. If I don't have a scientific calculator, then I don't have a pi button and I don't have a squared button. So I need to remember that squaring something means multiplying the number by itself. So I'm going to type into my calculator 3.14 times 6 times 6. And that's going to give me an answer of 113.04. And rounding this one to the nearest squared meter is going to give me exactly the same as I got using my scientific calculator. But that's not always the case. Our second circle we're going to calculate the area of is this one here. And it's got a diameter of 16 centimeters. And we're going to round our answer to 1 decimal place. So our formula is a equals pi r squared. But in this instance, I don't have r, I've got d for diameter. So I need to work out my r by halving d, and you can see there I've marked it in as 8 centimeters. So I'm then going to put that into my calculator, pi times 8 squared, and that's going to give me an answer of 201.061, and then it keeps going on. So I'm going to round to 1 decimal place. I'm looking at the second decimal place, so I'm looking at the 6. That's telling me that I need to round the 0 up to a 1, so my answer will be 201.1 squared centimeters. If I don't have a scientific calculator, it's the same thing. I'm replacing the pi with 3.14. I'm going to have to type in multiplied by 8 multiplied by 8 for my r squared, and that's going to give me a value of 200.96. If I round my answer to 1 decimal place, remember the 6 is going to round that 9 up to a 10, so the units column is going to change as well, and I must leave that 0.0 in my final answer because the questions asked me to round it to 1 decimal place. So my answer is 201.0 squared centimeters. So what if I want to work backwards and find the radius or even the diameter if I'm given the area of a circle? Well, I'm still going to use my formula a equals pi r squared. The thing I need to know this time is that the inverse operation of squaring is square rooting. And so the final step when we're working backwards with area calculations is that we will need to use the square root button on our calculator. So the example we've got here, one side of a coin has an area of 4.5 centimeters squared. What is its radius? And we're going to round our answer to 1 decimal place. So the radius is going from the center to one side of the coin. So we're using a equals pi r squared because you can see we've been given the area in the question, and it's 4.5. So we're going to substitute that into our equation, and we're going to get 4.5 equals pi times r squared. Now we want to do the inverse operation of multiply by pi. We want r squared on its own. So we want to do r squared equals 4.5 divided by pi. And this gives us an answer of 1.432. Now, as I said, the inverse process of squaring is square rooting. So we need to press the square root button on the calculator, and we will get an answer of 1.196. Now, we want to round that answer to 1 decimal place. So we're looking at the second decimal place, which is the 9, and we're deciding what to do with the 1 before it. The 9 tells us we need to round up, so our radius is going to be 1.2 centimeters. If I don't have a scientific calculator, I still have a square root button. So I'm going to do exactly the same steps, and I'm going to get r squared equals 1.433 because I'm dividing by 3.14 this time instead of using the pi button. When I square root it, I end up with 1.197, and rounding it will give me the same outcome as using my scientific calculator, a radius of 1.2 centimeters. Now, what if I wanted to work out the diameter? Well, as we know, the diameter is twice the radius. So we just need to double the radius. So 1.2 multiplied by 2 gives us a diameter of 2.4 centimeters.